This is the second method of factoring that we will see, and we're going to factor trinomials. And this is just the general form. A, B, and C are just numbers. We are only going to factor, for now, ones where A is equal to 1. So you won't see a number in front of x squared, like that. So here's an example already done. Now we've already gone from here to here. We multiplied. If you remember, we did x times x. We distributed. X times 4. We called it FOIL. It was really just a distributive property. 3 times x and 3 times 4. We combined like terms in the middle. Okay, so you don't have to do what I'm doing. I'm just showing you. See, we multiplied and got our answer. Well, if you look, that's now going to be our problem, and we're going to end up with what looks like a multiplication problem. So going in this direction was multiplying. Going in this direction will be factoring. Okay, so here's an example. So you're just given a trinomial. See, there's a hidden 1 in front of this. And step 1 says, open parentheses, place an x in each. So you write 2 sets of parentheses. You put an x here in the front of each. Now, if you noticed, I multiplied that 3 and the 4. That's where I got the number on the end. See, and also I added the 3 and the 4, and that's where that 7 came from. So what we're trying to do is we're thinking of two numbers that multiply to 15. We only have a couple options. You have 15 times 1 and 5 times 3. That's it. Well, which of those adds to 8? See, that would be the combining like terms in the middle part. Well, it has to be 5 and 3. So you put 5 and 3 in here, and you make sure your signs work. You have a positive 15 and a positive 8. That means you're adding both. And that's our answer. So our answer is going to look like binomial multiplication. And if you remember, we had an assignment called binomial multiplication. Okay, so we have some examples. You have to just kind of think of some numbers. Here, I'll tell you what. We'll just get started on. For instance, make your parentheses, put an x here and in front of each. Now think, what numbers multiply to give you 20? Well, you have 20 times 1, you have 10 times 2, and you have 5 times 4. These are the possible answers. But look in the middle. That's a 1. It's actually a negative 1 in front of x. Now, which of these pairs could ever add to 1? Well, 20 and 1 can never add to 1. 10 and 2 can never add to 1. 5 and 4 can add to 1 if one of them is negative. So you have to understand how to add positive and negative numbers to do this. So, which we know it's a 5 and a 4, but now it comes down to our signs. So think, if these two numbers are going to add to negative 1, the 5 has to be negative, the 4 has to be positive. I'm done. If, and you don't have to do this, but if I multiply this out, x times x, x times 4, negative 5 times x, negative 5 times 4, combine like terms in the middle, and there's your original problem back. Okay, so we'll do a couple more. We're not going to do this one because notice that number in front of b squared, the coefficient, is not 1. So in this assignment, we're not going to worry about those kind. So for example B here, we will use a's instead of x. Now 72 has a lot of factors, okay? So we normally don't work with numbers like that because a lot of people don't really even know them all. You know, 18 times 4 and 24 times 3 and so on. There are a lot of pairs, but most of us are going to rely on our math facts, okay? So I can tell you now, you start going through these pairs cannot add to 17, but 8 and 9 do. Now think, they add to negative 17, so they both have to be negative. Okay, I'll do one more, and I'm going to have you try D and E. So I'm going to put x's here. Numbers that multiply to give you this, that must add to give you that. Okay, now multiply to 18. You have 18 times 1, 9 times 2, 6 times 3. Which of these pairs could add up to 3? No, no, yes. If one of them is negative. Now, if they're adding to positive 3, which one has to be positive and which one has to be negative? 6 has to be positive and the 3 negative. Okay, if you want to pause the video and try these two, go ahead. I'm going to get them set up here. And here we go. 36. Well, we have 36 times 1, 18 times 2, 12 times 3. And we have 9 times 4. I think I just found it. I don't need to write 6 times 6 because 9 and 4 will add to 13. The 9 here, the 4 there. And they're both positive because they add to positive 13. Last one, factors of 24. 24 and 1, 12 times 2, 8 times 3, 6 times 4. Which of these could add to 5? The 8 and the 3. Now they're adding to negative 5. That means the 8 has to be negative and the 3 has to be positive. Okay, questions I normally get. Can the a plus 3 be over here and the a minus 8 over there? Yes, it's a multiplication problem. So the order doesn't matter as long as the 8 is negative. Okay, and the same here. This could read x plus 4 times x plus 9. If you have any, well, I'll show you the assignment first. And you will see it is just 12 of those. Okay, all of them have a 1 as the coefficient of x squared or a squared or whatever. Do your best. If you have any questions, let me know.